How do you understand this word, electrolysis? Electro, yes, and lysis. So, electrical current. This means to destroy. To destroy. Electrolysis is such a process when the particles, the substances, destroy under the effect of electrical current. Electrolysis is such a process when our substance destroys or separates into particles under the influence of electrical current. Let's continue. So, it's a process which occurs under, you see, it's a direct electric current. You see, it's written. We have two types of current, direct and indirect. You know that indirect current, it can change. Its hertz, its frequency can change. Direct, it's constant, you say. Its frequency is constant. You see, let's see this picture. Here we have a solution. Okay, this is a solution of our electrolyte. Sometimes we can use a melt, sometimes we can use a solution. It depends. Let's imagine that we take salt, the salt that you eat, you add to food. Salt is electrolyte. So we know last lesson we said that, not last, but the previous lesson we said, electrolyte is such a substance, the solution, aqueous solution, or melt of which conducts electricity. Okay, so salt, we discussed the sodium chloride is an electrolyte. Sodium chloride is an electrolyte. So it consists of ions, yes, sodium and chloride. But if electrolysis occurs in melt, in the case if the electrolysis occurs in melt, we will get these ions. If it occurs in water, we will get different ions. This time we will not talk about it. We will talk about it later. Now let's imagine that we take a glass. We take glass with water. This glass. And we have water here. Take salt and add the salt into water. We take sodium chloride, this one, and we add it into water. And we get aqueous solution of salt. Aqueous solution of salt. We get aqueous solution. When we discussed electrolytical dissociation, we said that sodium and chloride, they dissociate. Yeah? It was dissociation. In water, we have sodium chloride in form of ions, sodium and chloride. Ion is the atom which accepts or loses electron. Yes? Okay. So anion is a negative ion. Cation is a positive ion. Or it's always like that. If we say negative ion, it's anion. If we have positive ion, it's cation. Okay, just remember anion and cation. So what happens now? We have charged particles. Yes, in charged particles, it means there will be direction. We know that positive and negative charge are attracted to one another. Now, students, we take let's say two rows, okay, and add them here. 1 and 2. Add here 2 rows. And let's say one of them will be positive, one negative. Let's think like in the picture. This part is given negative. It's negatively charged. This one is positively charged. Negative. Okay, I will make them green. And this is positive. I will make it red. So these 2 rows, which have a charge. They are charged negatively and positively. They are called electrodes. These two ones. So these two rules, negative and positive, they are called electrodes. This one and this one, they are electrodes. We have two electrodes, okay, positive and negative, two electrodes. Well, what happens here? They are positively charged. In our solution, we have particles, positive particles and negative particles, yes? Here we add sodium chloride into our solution. What will happen? We will have sodium, yes, sodium plus particles, and chloride negative. In our solution, now we have positive particles, I will make them red, positive particles, sodium, yes, sodium. We have a lot of ions of sodium. They are cations. And we have negative ions, so we have cations. Anions. Yes, we have also chlorine anions. These are chlorine particles. Now pay attention. We said when we dissolve it in water, let's say, in the solution, we have sodium plus ions, we have chlorine minus ions. There is plus and minus. We know that plus and minus are attracting each other, yes? When we have plus and plus, they will repel each other. It's like a magnet. If you take north and north of magnet, two magnets in the same pole, they will just repel each other. You try to make and they will repel. But if you take the opposite poles, they will attract. The same here, the opposite charge scenario, they attract each other. Okay, this one is positive. It means our negative particles will move on this direction. So this is what we will get. Our negative particles will move in this direction. Okay. There. Because minus and plus are attracted. This one is negative. Yes? It's minus, negative. Positive particles will be attracted by the negative cathode. So the plus will move in this direction to this cathode. So what happens? Under the electrical currency occur the dissociation. They separate, they dissociate, they destroy, and move in this direction. Yes? But actually, indeed, we will take this one. There will be sodium hydroxide, there will be hydrogen, etc. But now we are not talking about details. Now we are just trying to understand what electrolysis is. Okay? It's not a detailed information. It's just introduction. Anions come here. This will be anode. It's called anode because it attracts anions, so it is anode. This one, how will we call this one? Yes, because cations move in this direction. He attracts cations. It will be cathode. Okay, so anode. Why anode? Because it attracts anions. Cathode, because it attracts cations. Cation is positive, but cathode is negative. Anion is negative, anode is positive, opposite. Why? Anode attracts anions. If anion is negative, anode should be positive. Electrodes, anode is positive, yes? Right, it's plus. Positive because it attracts anions. Second one is cathode. Cathode is negative because it attracts cations. And let's write here ions. Anode is positive. It attracts anions, but anions are negative. Cations are positive. That's right. Cations are ions, particles. These particles, cations. Cathode this role. Okay, anions are these negative particles. Anode is this role. Okay, this role. Okay, let's now see how it works. Okay, we talk electrolysis, anode, cathode. Let's talk about a bit more detail about it. So again, this is what I drew in the picture. You see, we have a solution of electrolyte. Yes. This electrolyte, is dissociated in water in aqueous solution. It dissociates into ions, positive ions and negative ions. Yes, anions and cations. We can see them, anions and cations. This is the orange one or anions. The blue ones are cations. It's our electrolyte. DC is direct current. DC, direct current. Okay. So this is a source of direct current. For example, we can take a galvanic element as a direct current. And these are our electrodes. Okay, cathode. See, cation, cathode. And you see the accumulator, they all are attracted by cathode. At the end, all of them will be like these two ones. They will accumulate on the surface of cathode. Yeah. All the negative particles or the anions will move and come and they will be accumulated on the anode. Here you see two ones have already attracted by it. These ones are now moving. They will move and finally they all will start there, stop there. And when all the cations come to cathode and all the anions accumulate on anode, our process stops. Okay? The electrolysis process stops here. There is such a term that is called electrical potential. Okay, electrode potential. Here we will type potential. Electrode potential. What is potential? It's from the word poter. Latin word poter is to be able to, can. Yes, poter. Latin. So the word potential is derived from the word potent. Yes, potent. One that can, who can do something. The word potential derives from this word. The word potential derives, it means their ability to do something, potential. This, we say spare. Okay, limits. How much he can do something. He can do something. Potential here it means how much we can do something. In our case, what is this something? Electrolysis. Yes. In our case, this something will be electrolysis. How much it can do the electrolysis? How much our electrode can do electrolysis? Like its strength. Let's say its talent. If our electrode is very talented or not so much talented. Okay? Potential shows the ability of electrode to do something. If you have much strength, much potential, you will spend less energy. It means the one has higher potential, so requires less energy, that will do it first. Imagine that we have several electrodes, a lot of electrodes, but one of the electrodes will work. One of them, which requires less energy, so has a higher potential, that anode will participate in the process. Okay, so when we are talking about electrodes, we are talking about their potential. You said the order in which direction, order of discharging. Discharging means like when ions come and discharge them. Discharge, it's charged minus, it's charged plus. When cations come on it, it becomes negative. For example, if it's plus 10, when it gets 10 negative particles, it will be minus 10, overall will be 0. It will be discharged. This is minus 10, it will get 10 positive particles, and it will become 0, yes, minus 10, and they will have positive and negative charge. Negative charge, they will discharge it. But in which direction it goes? First, this one is discharged or this one? To see the order of discharging, which goes first, we look at their potentials. The one who has a higher potential, a bigger potential, the one which requires less energy, will be discharged first. So electrode potential, we said here, potential is ability to do the process, to do the electrolysis. Yeah? It's electrode potential. It's an electromotive force, but it's a force that we use it. For example, let's imagine that Adela comes to the to the dormitory, yes, and she needs to cook something to eat. Adela and Mingyu are hungry and they want to eat something. They are very tired. They don't want, after classes, they are tired and they do not want to cook it. But they anyway go and cook. Something makes them cook it. Okay? Nobody says, hey, Adela, cook. Nobody says it. But she goes and cooks food. Why? Something moves you. Yes, something makes you. What makes you cook the food? Your hunger. You are hungry, you need to eat. If you don't eat, you will suffer, you will feel hungry. So this hunger makes you cook something. This is called electromotive. Your hunger, in your case, is an electromotive force. In the process of electrolysis, electrode has an electric potential and the electromotive force of it. So it comes from motion, to move. When was the standard? Look, it never changes, it's always standard. It's a measure of the ability of a species. Species means particles, atoms, ions, molecules, okay? Species to gain or lose electrons. Species which gain electrons is said to be reduced. As you remember from oxidation reduction reactions, when they get electrons, they get reduced. So it's reduction. You say they are reduced. When they gain electrons, they are reduced. It's reduction process. And then when they lose electrons, they get oxidized. Let's see electrode potential. Indeed, we cannot measure the electrode potential. Usually they are given, yes. Sometimes it happens like we cannot measure it. It's not that we cannot, we don't need to measure electrode potential. Usually electrode potential is given. We have two electrodes, okay? Each of them has its potential. And if there is a difference in this potential, this will be difference of potential. Look, difference of potentials, sometimes we call it O, or we say E. Electric potential of the cell. What is cell? Potential of cell, electric potential of cell, is this whole. I have already erased it. Let's go to the previous slide. Look. Like this. This overall is cell. Anode, yes, cathode, electrolyte, and all the processes going. This all together is called cell. If we take a galvanic element, as I said, in the galvanic element, we have electrolysis process. So it will be our cell overall. Imagine that this is our galvanic element. Okay, this is, let's say, this part is positive, this part is negative. So this part, and here we have indeed some acid inside of the galvanic element that we do not see, it's inside. And it's written that this is 1.5 volts. Yes, it's voltage. It will be E cell. We say E of cell. This is what is written on battery. This is what we have. But how do we find it? We find it by this formula. We take electrode potential of cathode. It's cathode, yes. Electrode potential of cathode minus electrode potential of anode. And that's why we call it potential of the cell, or we call it difference of potentials. This will be called difference in potentials. Yes, okay. This is potential of the cell. Okay, even here you can see it. You see our cell in this formula I wrote here. Particles go on the surface of cathode, yes? So it means that interface between an electrode, like electrode potential, is on the surface. It appears on the surface of an electrode. Look, cell potential, look, it's written here as a definition, yes? Is the minimum potential needed for the electrolysis process. It depends on their ability of the individual ions to absorb or release electrons. Cell potential is what we have. Cell potential, like it's a difference of potential, here is 1.5 volts. But the minimum potential that we need, for example, you take 1.5 volt of galvanic element, put it into the small lamp, it will shine. But if you take a very big projector, big lamp, and you add the 1.5 volt galvanic element, in this case, there will not be anything. It will not affect. It will be small. Because for bigger lamps, we need big batteries. Yes? So the minimum potential that we need for small lamp, maybe 1 volt is enough, we give 1.5, okay. But for a bigger one, maybe we need 300 volts. Of course, 1.5 volt will not be enough. So it's called the minimum potential. And the minimum potential which is required for the electrolysis process, you see, it depends on what? On the ability of the individual ions to absorb or release electrons. For example, we have an ion, yes? This ion, if it's a positive ion, if it's a cathode, it will absorb electrons, yes? So in our case, this cathode is negative, yes? It will absorb cations, it will take cations, this ion, but it will not take the anions. If it's anode, if it's positive, it will attract, it will absorb negative ions. So its ability, it can affect a lot of electrons or less electrons. So this affects the minimum required potential. So minimum potential depends on the system that is required for electrolysis. Depends on the ability of individual ions to absorb or to release electrons. Let's talk about Faraday. So when we are talking about electrolysis, we have to remember Faraday's law. He has two laws, this man. So laws of Faraday or Faraday's law for electrolysis. Let's see what these laws are and why they are so important. So on the screen, you can see the first law of Faraday. If you do electrolysis, its mass of the substance that appears on the electron will be equal to K is like constant. It's constant, it will be given. K. Q will be charge. The charge of electrode. And if we are talking about Faraday's second law, look, this is how many calories per mole of energy we obtain. It's called farad, 1 farad, like calories per mole. In order to find it, we take what we take. Avogadro number multiplied by the electron charge. Sorry, electron mass, not charge. Okay, and we will get this result, this number. It's equivalent, not okay. We write E, but don't get confused. Potential goes for electrons. Here we use E, but it's called equivalent concentration. Okay, with the equivalent concentration, divide by this number, by farad, this number.